Hello everyone, my name is Dr. Chris Hacks, and welcome back to another tutorial on how to do the CryptoPals Crypto Challenges. Today we're going to be looking at Challenge 1. In this challenge we're going to be converting a hex string to a base64 string. So for those who are not familiar, hex is a way of encoding data using only 16 different characters, and then base64 uses only 64 different characters. So let's first read the challenge and then I will go through the solution. So we have this long string here encoded in hex, and it should produce this long string here in base64. So pretty straightforward. Alright, so let's jump right into the code. I'm going to copy this challenge for our convenience, and let's come over here. Okay, so we have challenge 1 right here in our header file. Let's go ahead and do this. First off, I'm going to add a new filter. We're going to call this set number 1, and we'll do this just to keep everything a little bit more organized. Okay, and then we'll have a new item. We will call it challenge1.cpp. Perfect. All right, I'm going to throw this up here just so we have it for our own reference. Bring this down a little bit. Okay, now we will do include challenges.h, so we have it, and then std string challenge1. Okay, perfect. So for our hex encoding and our base64 encoding functions, we're going to be using them multiple times throughout this challenge. So what I'm going to do over here is I'm going to create a new header file, and we're going to call it encoding utils.h. Okay? Alright, perfect. So with encoding utils, this will allow us to access all of these different encoding functions that we're going to be building throughout these series. So what we're going to need is we're going to need two functions for hex, one to encode and one to decode, and then two functions for base64. Same thing, one to encode and one to decode. So I'm going to include string here. And I'm also going to include a couple of other headers that will be useful for our encoding and decoding. So I'm going to include ctype. This will be used for the base64 functions later on. There's a couple of things here like the is hex digit, the to upper, and the id digit functions, part of the standard library. We'll be using those. And then also we're going to include vector just because that's always useful to have, and we will be using it for some of the tables later on. Okay, cool. So now what I'm going to add in here is all of our declarations. So like I said, there's 4 different functions, so let me include all the declarations for them. We'll call this one text to hex. That will be our encoding function for the hex string. So we'll use a constant string, and we'll have a reference to it, and I'll just call it input for now. Just keep it simple. Oops. Okay. For our next function, they're all going to have the same exact signature, so I'll keep it easy. This one will literally just be hex to text. Simple and easy. And then we're going to have 2 more. These are going to be for base64. So we'll have text to base64, and we will have base64 to text. Okay, perfect. Put that there. All right, very cool, very cool. Now we have all of our different declarations for our functions. So now let's go and actually define them. So I'm going to copy all of those there. I'm going to make a new file. In our sources file, let me get rid of this resources thing. We will not be needing this filter. We'll just put this in our sources file. We'll add a new item, and we'll call it encoding utils.cpp. Perfect. Okay. So we need to include our header file, so encoding utils.h, and then all of our function declarations. Okie dokie. Let's start with our hex functions. Our hex functions are going to be the easiest to implement and the easiest to explain. Okay? So, first thing is first. What we're going to want is we're going to want a table to actually look up all of our hex characters. So let me put this up here. Static const std string hex characters, or hex chars. While not a table in of itself, it's just going to be a string. It's going to store all of our hex characters that we'll be using, which will make our life a lot easier. And I'll show you why in a little bit, but let me just put those in here first. So for hex, we have 0 through 9, and then A, B, C, D, E, and F. So when using hexadecimal, it's just like another counting system. So we have all of the normal numbers, 0 through 9, that you'd see in normal counting, and then we don't have like a character for 10. So what we're using is A. Then like B would be 11, C would be 12, and so on and so forth. Okay, so that will be our little counting system, and that stores all of the information for us. Okay, so let's get into this function. First thing we're going to need is a string to store our output. So I'm going to call this output, plain and simple. And then let's reserve the length for it. So output.reserve input.length times 2. And the reason why we're doing this is it's just an efficiency thing. We'll make sure our string is long enough to hold the input length. And every single character is going to turn into one hex character. So what do I mean by that? Let's just go through an example. So let's take the equal sign here. The equal sign is an ASCII character, has a value of 61. Okay? So when we have 61, in binary, this is what that looks like. It's going to look like this. So each character is 8 bits large. So you got the 128, which is 0. The 64 is 0. 32 will be a 1. 16 will be a 1. 8 will be a 1. 4 will be a 1. 2 will be a 0. And 1 will be a 1. Okay, cool. That's our binary representation of 64. In order to convert it to hex, it's actually very simple. We can just split this 8-bit string in half, and then each of these 8 bits is going to be one hex character. Let's count this. So this is going to be 1, 2 is 0. Okay, 1 plus 4 is 5, plus 8 is 13. So let's do that. A is 10, B is 11, C is 12, D is 13. So this right here is going to be a D. Okay? Oops, not that. We'll just put a D right here for now. Okay? And then this other half of the hex character is going to be 1 and 2, which is just 3. So 61 in hex is just going to be 3D. That's what our program is going to be doing. Okay? So to actually implement that, it's going to be very simple. We're just going to have a simple for each loop. So for each unsigned character in the input, what we'll do is we'll look at the top 4 bits and the bottom 4 bits of the character, because each character is going to be 8 bits. So the top 4 bits will be our first part. So output.pushback hex char C, and then we're going to look at the top 4 characters. So what this is doing is it takes the top 4 bits and then checks our lookup table. So our lookup table, each of these characters is in order. So whatever this value is, let's say for example it is going to be this right here, 3, it's going to shift these 4 bits over here. So it's going to shift this, this would be, 32 plus 64, so this is 48 right here, but it would shift it. So this would become 1, 2, 3, 4, and then, so we got 3 right there. So it's going to look at 3, it's going to look at the third character here. So 0, 1, 2, 3, it's going to see a 3, and it's going to put that in the output. And then the next thing we're going to do is output.pushback. The same exact concept, except with the lower 4 bits. So the way to get the lower 4 bits of a character is to AND it with 0x0f. What this is doing here is it's basically taking 0x0f, which is going to look like this real quick. It's going to look like this. So only the bottom 4 bits are going to be included. So by doing this, we can effectively convert each character, the binary in each character, into hexadecimal. Okay, so very, very straightforward. It's just a little bit of bit manipulation, and then we can just return our output, because that will do that for every single character, and it will convert our, our text, our string, into hexadecimal. And it doesn't matter what's in the string. Each character is going to be looked at, and its ASCII value will be converted to hex. Okay, perfect. So that's our first function down. All right, let's take a look at our second function. Hex to text. So this one's going to be a little bit different. It's also not too tricky, but it will be a little bit less efficient. There's going to be a couple more steps. All right, so first let's make sure to validate our input. With the text to hex, you can put in any text you want and it'll convert it to hexadecimal. However, with hex to text, you can only put in a hexadecimal string, and that's going to follow a certain form. So first off, it's always going to have to be a even length. If it's not even, then that means one of the hex characters is missing, and that's not a valid string. We're not going to throw any errors or anything. All we're going to do is we're going to return a blank string. Now, I know that's not a great practice. You might want to throw an error just so that you would know that it is not working correctly. If you want to throw an error, that's completely fine. You just include the standard exception header, and if you do that, then you can throw errors. But for now, I'm just going to make it return an empty string. So if input.size modulus 2 is not equal to 0, that basically means it's not even. Okay? If it's not an even length, then we're just going to return an empty string and move on with our day. Okay, and then the next thing we do want to keep making sure this is valid just for later debugging purposes. So I'm going to also make sure that every single digit is a hex digit. So the way to do that is there's a built-in function we're going to use. So we're basically going to iterate through every single digit in the input, or I'm sorry, every character. And basically, if it is not, and we're going to use this standard library function is x digit, just checks if it's a hexadecimal digit or not. If it is not a digit, then we'll return a blank string. And this function, as you can see, it's expecting an integer. It's not expecting a character, so we have to static cast it. So we'll static cast unsigned char, and then our character. And that just makes sure that our signed character becomes unsigned, and then the conversion between int and character is the same. So that should be good. All right. Oh yeah. And if it is not a hex digit, then we are going to return a blank string. Okay, very cool. Very cool. Okay, now we can actually start converting our hexadecimal into text. So once again, we will get our output string, so string output, and then we will do output dot reserve, and we're going to reserve the input size divided by 2, basically the opposite of what we did earlier because it's going to be half the size. All right, very cool. Now for each 2 characters in this hex string, we're going to convert that into one ASCII character. So we can do a for loop. We'll use a size t because we're only working with positive numbers. All right, I is less than the input dot size, and then I plus equals 2 because we're going to look at every 2 characters. Okay, so when working with binary, every 4 bits is called a nibble, and every 8 bits is called a byte. So we're going to call this our high nibble and our low nibble, just to keep the same terminology. And you might see that terminology in like a computer science class. It's not super common because nibble is not worked with as much as byte is, but that's just the name in case anyone was wondering. All right, so we'll have our high nibble, and we will set that equal to the input, which is just going to be the first character, and then our lower nibble is just going to be the next character, which would be input plus 1, or input of I plus 1, like that. Okay, so that will get us our 2 nibbles, and then we can work with them. All right, so our actual byte, first we'll keep it as an int, just so we're working with a number. We'll call it byte. And then all it is it's going to be this. So first, we'll work with our high nibble. So we're going to do std.isDigit to check if it is a number or not. And then high nibble. We want to know if it's a number. That way we can convert it correctly. If it's a number, then we're going to subtract the ASCII character 0. that will convert it from, like 0 in ASCII, which is 48. That will subtract 48, and then the representation will be a pure integer. That'll just make our lives a little bit easier to work with because we have to convert it from a character to the integer value. Okay, but if it is not a a digit, then we want a character. That means we're working with a character and we have to convert it a little bit differently. So we're going to do high nibble and then minus a, which is the first character. And then we're working with lowercase characters here, so we can continue to work with lowercase. If you guys want to work with higher uppercase, make sure this is uppercase as well as this. It really doesn't matter. It's just you have to choose one or the other. Okay. And then we're also going to add 10 just because the A, B, C, D, and E, those are 10 higher because they're representing those like larger numbers. All right, so this is our higher nibble, and then also we have to shift it 4, which is the same as like multiplying by 16. The reason why we shift it 4 here is because we need to make sure that this integer is in the upper 4 bits. Okay, and then once we do all of that, then we can add it to our lower nibble, which is going to be exactly the same, except it's just not shifted 4. So let me copy and paste that, and then we'll change this to low nibble. And then I can just go through and change it here. Low nibble and low nibble. All right, and that's all it is to it. That's all you have to do to convert from base or hexadecimal to a string. And then once we get our byte all ready, we can just add it. Output dot push back. We do have to static cast it. Char, and we'll put in byte. We do have to cast it to a character, and then we just return output. Okay, and that's all there is to it. Now those were both the easy functions. Base64 is quite a bit more in depth. There are a lot more steps just because it's not so easy. With hexadecimal, it's very simple because 1 byte is just 2 hexadecimal characters. However, with base64, there's a little bit more nuance to it. So we'll go over all of that. Now, the first thing that I want to do when I'm converting to base64 is, like with hex, I want to have a table. So what we're going to have here is we're going to have a static const string, and we'll call this base64 chars. Okay? Or let me add an S to the end of this just so that it is a little bit more accurate. We'll call it chars instead of char. Okay, I think that should be good. All right, and then I'll just put an empty string for here so there's no errors. Okay, so with our base64 characters, it's going to be a little bit different. So the alphabet for base64, I actually have it in my notes over here. First, we're going to grab, I'll just grab it and then I'll explain it. So what we'll do is we have all of the uppercase letters, all the lowercase letters, and then all of the numbers. So we have 26 plus 26, that is 52. And then we have 0 through 9, that gets us up to 62. And then we use the plus sign and the slash to get us to 64. So we have 64 different symbols to represent our encoding. Okay? And then also, along with our encoding, we want this little helper function to help us check if a character is in base64 or not. Now the way to do that is we just use a static inline bool function. Oops. If I can spell today. And then we'll just put is base64. This will become useful later. All you have to do is pass in an unsigned character. And then what we're checking for is just if it is either a alphanumeric character, like that. And then we're also going to check if it is either a plus, like this, or whoops, not an equal sign, a plus sign, or if it is a slash. Like that. If it is one of those characters, so if it's, alphanumeric or a plus or a slash, then it is a base64 character. We'll be using this for validation in our decode function. So I might as well just throw that in there for now. All right, once we have all of that set up, we can start working on the encoding function. This will take any text and convert it into base64. Okay, so the way to do this is a little bit complicated. Basically, what we're going to be doing is each 3 bytes in our text is going to become 4 base64 characters. So it's kind of a little bit of a more complicated conversion, but it's not too tricky. So the overall process is we will look at 3 bytes from our text, and we will make that into 4 characters, and then at the end we'll add some padding based on what we have left over. So let me just start coding, and I will go step by step explaining what everything is. Alright, so first we're going to have our string output, and we are going to also reserve something for it. So output.reserve. For now, I'm just going to put input.size. I will come back to this and we'll explain what size we're going to be using. So first, we're going to have a for loop. So for int, size t. We have to use that because we're working with non-negative numbers. Equals 0. It's going to be less than the input.size. And then we're also going to increment by 3. The reason why is we're looking at every third character. Every group of 3 characters. So let's say, for example, we have A, B, C. We're going to look at all of that, and we're going to convert that into 4 base64 characters, okay? Whoops, let me get rid of this so it doesn't get all mad at me. Okay, so we're going to have an unsigned integer that is 32 bytes. 32 bits large. We're going to call this 3 bytes. Okay. Now I know unsigned int 32 is actually going to be 4 bytes large, but this will give us enough space to hold our 3 bytes. What am I missing? Oh, I need the unsigned int. It's a different way of typing it. Unsigned int 32 underscore t. There we go. Alright, that's the type we'll be using. And then also we're going to hold a counter variable called bytes to process. So size t bytes to process. This will be useful later. I'll show you guys why in a second. Alright, so for size t, we'll call it j equals 0. J is less than 3. And then j plus plus. You can do plus plus j if you want, either or. Alright, basically we want to make sure we don't go past the end of the input while we are looking at each individual character. So the way to do that is just I plus j has to be less than input.size. That way we don't go past the string length. If we do that, then that would be bad. So we've got to be memory safe here. Okay. So the way it's going to work is 3 bytes is every single byte we look at, we're going to shift it. So let's say, for example, we have, A, B, C. What we want to have is we're going to have 8 zeros first. 1, 2, 3, 4, 5, 6, 7, 8. And then we're going to have the representation for A. A in ASCII, so let's just check what it is. It'll tell us right here. A in ASCII is going to be 97, okay? So what we want to end up with is the ASCII representation for 97. So it's going to be 64 plus 32. That gives us 96. And then 97 is just going to be a 1 at the end. So 16, 8, 4, 2, and 1. So that's our representation for A. Okay? So all we're going to be doing is we're going to be putting that into this 3 bytes variable like this with A here, B would be next, and then C would be next. Okay? The way to do that is using the OR function. That way we'll just have, right now 3 bytes is just 32 zeros. So all we can do is or equals, and then what we'll do is we'll do a static cast unsigned int 8. That will be 1 byte. And we're going to take our input, I plus j, that's the current character we're looking at, and then we're going to shift it. We're going to shift it by this amount. So every single one of our shifts has to be a multiple of 8. However, when we have j is equal to 0, we're going to want to shift it 16 bytes. That way, like for example this, let me copy this a couple of times. Let's just say we have AAA right here. We want this right here to be shifted this many. So let me just put a couple of zeros here real quick just to make this clearer. If we shift it by 16, it's going to go 8, 16, and end up in this position. Okay? And then for the next one, we want to shift it by 8. So it will be right here. We're going to shift it by 8. It's going to end up in this position. For the last one, we don't want to shift it at all. It just needs to be in this position. So it's really easy function formula right here. We're just going to shift by 16 for the first one. And then for the second one, which will be j equals 1, we'll just shift by 16 minus 8, which is 8, which will be this right here. So that will shift it like this. The first A, the first character, will be shifted by 8, 16. It will end up in this position. Second character will be shifted by 8, so it will end up in this position. Third character will only be shifted by 0, so it will stay where it is. And then by ORing this with 3 bytes, we can end up with a bitwise representation that looks like this, which will be what we use next. Okay. And then we also are going to increment bytes to process. So bytes to process plus plus, just to increment that. Now that we have our 3 bytes, we can convert that 3 bytes into an actual 4-character 64-bit, base 64 representation. All right. So we have to generate 4 characters. So 4 size t of k is equal to 0. We will do k is less than 4 because we're going to be making 4 characters, and then k plus plus. There we go. All right, so if k is less than bytes to process, we're going to do a couple of other things. So we got to make sure that there are 3 bytes to process. If this condition is hit, then that means that bytes to process will not be incremented, and that means we're going to have to pad the end of our base 64 representation. But I'll get into padding in a little bit. First, we'll just process our bytes. So that means we have 3 bytes right here in our 3 bytes unsigned int 32. We have our 3 bytes to process. So what I will do is for every single 6 bits, we're going to turn 6 bits into 1 character. Okay, so if we look at this, this is going to be 24 bits right here. 6 divided by 24 gives us 4. All right, so that's the conversion. So we will do unsigned int 8 type, and we're going to call this 6 bits. If we can spell 6 bits. Okay. Let me also call this 3 bytes just to keep my naming convention all the same. Just keep everything consistent. All right, so our 6 bits that we're going to process are going to be this. So we need to isolate our 3 bytes. We are going to shift it, and the formula is going to be 18 minus 6 times k. And the reason why is because of this. We want to grab these 6 bytes first, okay? Process those, then grab these 6 bytes, then these 6 bytes, and then finally the last 6 bytes. And the way to do that is with this little formula right here. Very similar to what we were using, the same idea, where every time k gets incremented, the 6 will grow bigger and it jumps down 6 bytes. Okay, once we have those 3 bytes, what we're going to do is we are going to AND them with all ones, just to make sure that we're only getting the 6 bytes. So like say for example, we're looking at these 6 bytes, all of these are still going to be carried along. So we have to get rid of them. And the way to do that is just AND it with 6 ones. The hexadecimal representation for 6 ones is going to be 3F. So if we AND it with that, that will leave us with just 6 bits by themselves, and everything else will be all zeros. Okay? So once we add that, we have our conversion done. We have the character and the number representation for it, and we can just look it up in our lookup table from earlier. So up here, let's say we're looking at these 6 bits right here. This is going to be binary 000, so 1, 2, 4, 8, 16. So this will be binary 24. Okay? So if we go to our 24th character, that is going to be X. The first character will be an X. All right? And then we can just add that to our output. So we'll do output dot pushback, and then all we have to do is do our base 64 characters, and we will look up 6 bits like that. Perfect. Okay, and that's the conversion. That's all there is to it. It is a bit more complicated than the hex, but it is a little bit better. It is a little bit it's not too tricky to understand like some of the stuff we'll be looking at later on. Okay, and then finally, I also have to make sure to include this. Oh, let me make sure I put it in the right spot. If there are no bits to process, let's say, for example, our text, if you were to subdivide it into, multiple subsections and it doesn't line up perfectly, then we can just append some equal signs with this. Output.push back, and then just an equal sign. Okay? Once we add those equal signs, that will make sure that our 64-bit output is the right size for the standard. Okay? Now, that's all there is to it. Oh, I do have to mention, we do have to go back to our reserve. Now that we know the little ratio, it's going to be like this. What we want to do is roughly estimate what our size will be. So let's do this. For our size, let's add 2 to it. I'll show you why in a second. Okay, and then we are going to divide by 3 and then multiply by 4. So the reason for this is every single 3 characters in our text is going to become 4 base 64 characters. So we have to divide by 3 and then multiply by 4. However, remember how I said the text might not always line up perfectly? That's why we add this 2. This 2 that we're adding represents the 2 equal signs we can potentially have. Every base 64 string can have either 0, 1, or 2 equal signs at the end to make sure the padding is the correct size. So we will just add this to make sure that our output string is the correct size. All right, now once all of this is said and done, we can just go ahead and return our output. And then there's a couple of ways to do this. If you go on Stack Overflow, for example, there are probably like 3 or 4 different mainline ways to convert between text and base64. This is the one I'm choosing to use, but there's a couple other approaches. So if you guys want to do some research after this, feel free to go and look into that. Okay, so finally we have our base64 to text function. This is our last function. It is also probably one of the longest ones, but just like the base64 or text to base64, it's about the same level of complexity. Okay, so here's what we're going to do. We're going to be using a lookup table. Now, you can hand code this lookup table into the code itself if you do want to be more efficient. However, I'm not going to do that. So we will have the code do it for us. A little bit less efficient, but it is easier to write. So we're going to create a vector of integers, and we're going to call it decode table. And for now, what we can just fill it with is 256, there's going to be 256 entries, and we'll just put -1 just to populate it for now. And then we're going to actually go and populate it ourselves. Because we are working with, let's see, I believe we can use size t here. We can use size t. I believe everything will be a positive character. So size t of I equals 0. And what we'll do is I is less than 64. And then plus plus I, or I plus plus. The reason why we'll have this is because there are 64 different symbols in the base64 alphabet. So we'll just go ahead and we will use that. All right, so continuing on, we're going to keep building this decode table. So size ti, blah, blah, blah. All right, so for the decode table, what we're going to do is for every single element in it, all we have to do is the static cast an unsigned char, and then what we're going to do is we're going to grab from our base64 chars, base64 underscore chars I, and it's just going to equal I. Okay, this just builds a simple decode table. Okie dokie. Alright, once we have our decode table, now we can actually start building our string. So std string, call it output.reserve, and we can just more or less do the opposite of what we did. Because of the padding, we don't know the exact size. So let me just show you what I mean by that. The padding makes us add 3 instead of 2 from last time, and we can just divide by 4 because for every 4 base64 characters, we're going to have 3 normal ASCII characters, like that. Okay. Alright, so now we can add all of our normal variables. So we're going to add int, and we'll have bits collected. I'll show you guys why this is useful in a second. And we're going to have an unsigned int called our accumulator. Both of these will be used for counting up the number of bits we've been looking at and basically accumulating the 32 or the 24, I guess in this case, bit value. We're going to use a 32-bit int to store this, but 24-bit value for the 3 characters that we're retrieving from the 4 base64 characters. Okay, so let's actually go through the base64 string. So for every unsigned char, C in our input, we will take a look at it. So the first step is to ignore the padding. So I'm just going to add this at the beginning. If we have padding, then we're just going to straight up ignore it. The padding will always be at the end of our base64 string. So once we encounter it, we know that all of our meaningful data is ended. We know that the data is of the right size, it has the right number of bits because of the base64, the equal sign at the end, but that means there's no more meaningful data after it. So we can actually just break out of our loop if we encounter it. Okay, and then we will look up our base64 value in our decode table. So int decoded value equals, or let me name this correctly, C is less than 256, and we are going to check our decode table. If it's in there, great, we have an integer value for it. If it's not in the decoded table, then that means it's an invalid base64 character. Okay? For any invalid characters, you can do one of two, like 3 things. You could either skip it, you can return a blank string, or you can throw an error. For now, I'm just going to skip it. So what we'll do here, oh, I forgot, I need to put parentheses around this. So if it's a invalid character, I'm just going to skip it. So I'll just do continue. If I can spell it. And the reason why I'll just skip it is just in case there shouldn't be any instances of invalid characters. Like if we run into like a new line character or something, we should just skip it. But later on, we will be monitoring the input we put into these functions, so it should be fine to skip it. However, if we run into issues, then I can come back and change this to an error. If you guys want, you can throw an error, but for now, we're just going to skip any invalid characters. Okay, very cool. Now let's go and actually start converting. So what we'll use is we'll use our accumulator to take every character, take the 6 most important bits for it, and then add them to the accumulator to actually get that 24 bits, the 3 characters we care about. So for our accumulator, what we will do is we'll shift it by 6, and then OR it with the decoded value. And that will effectively convert each of those base64 characters, those symbols, into the correct 6 bits for our accumulator. And then we can just increment bits collected by 6 so that we can keep track of that. Alright, and then after that, if we've collected at least 8 bits, then that means we can actually extract a character. If we have less than 8, then there are no valid characters in our accumulator, so we don't want to try to extract it. So what we can do is we can do unsigned character, and we'll call it our byte, and it's just going to be the static cast. We're going to cast an unsigned char, and then what we'll do is accumulator shifted with bits collected. I believe that's it. Oh, I do have to mention we do have to XOR the lowest bit. That way, if there are any characters at the top in the like say for example we have like a character like a bit up here that's a 1, we want to ignore it just so the bottom 8 bits are significant. So we will make sure to XOR it. I'm sorry, we'll make sure to AND it with 8 1s down here. Okay. So we can do this. Let me just make sure everything's correct. We'll static cast the accumulator after shifting it, then we'll static cast it and AND it. I believe that's correct. Oh, I forgot the okay, there we go. Cool. Okay, and then once we have our byte, we can just do output dot push back, and we can push back our byte, and that will give us our regular text character. Okay, and then once this is all said and done, bada bing, bada boom, we can return our output. Perfect. Now that our output's returned, everything is all dandy, and we have our base64 to text. Alright, so that was all the hard stuff. Now we can actually go and do the challenge. Make sure this is saved, so we can actually do challenge 1. Now if I go back to challenge 1, we have this string up here. So I'm going to throw this in a string. So const string, we'll just call it hex, and throw that in there. Okay? So that is the hex string. We want to decode the hex string, and we also want to convert it into base64. Okay? So we have the functions to do that. Let me just make sure to include the header. Include encryption or encoding utils.h. Perfect. Now we can just do std string, call it plain text, Yeah, because this would be plain text, equals hex to text, and we'll put in the hex string, and that will give us the plain text. Now we want to actually return our base64, so we will do text to base64. We put in our plain text string, and we can return that. And now challenge 1 is complete. So let's go and actually verify that. So here we have our main function, and if we go ahead and run it, make sure everything compiles and runs, you can see that is not correct. Something went wrong. So that means something is definitely wrong with our base64 encoding function. Something went wrong there. So let me go take a look at that, and we will figure out what is wrong here. Alright everyone, sorry about that. I did a little bit of debugging and I figured out what went wrong. I found 4 different places. So let's just go over them real quick, and then we will go through everything again. So right here, I realized I switched the D and the E, so I made sure to switch that back, make sure that's correct. So that was one spot I messed up on. Over here, I was using a plus instead of an or. I should have been ORing the bits together, not adding them. For some reason, that was causing some issues, but I found that ORing it fixed that. It might be a little bit of an order of operations thing, potentially, but regardless, this fixed the issue for the hex to text function. Over here, the parentheses were a little messed up, so it was grabbing the wrong symbol from the text to base64 thing. So there should have been a parenthesis here right after this bracket. So that was a little something. And then also one more, k is less than bytes to process. That should be a less than or equal to. It was just a less than earlier. So if we run it, now we can see here's the plain text after it's decoded from hex, and then here is the correct base64. So that's challenge 1 complete, but real quick, let's just go through some testing guidelines. So one of the things I would like to test is all of our functions. So let's just go through it. So we already have our hex to text function tested here. Here's our plain text. Now what we can do is let's test it going back the other way. So what I mean by that is text to hex. We want to make sure all of these functions work properly. So we can put our plain text in here. And then if we do this, that will allow us to make sure that this function, the text to hex, actually works correctly. And then finally, we got to see text to base64 works correctly. What I'm going to do is I'm going to throw that into a variable like that. And then what we will do is we'll check, hey, let's see, let's do cout. Let's make sure that the base64 to text actually works. Alright, perfect. And then we can just return our temp string for now, and we'll come back and clean this up when we're done. So let's just go through, make sure everything looks good. Alright, so if we compare our hex to here, this appears to, this appears to match. Okay, we can see that our base64 decoding is not working correctly. It should be saying this up here, not this. So real quick, I'm going to go through and debug that, and then I will let y'all know. Alright, so luckily this was a pretty easy fix. I forgot one line of code right here in the base64 to text function. After we check to make sure the bits collected is greater than or equal to 8, we have to actually decrement it. If we don't decrease this value, then we're just going to be looking at the same character over and over, like 4 times in a row, which is not what we would like. So we have to make sure to decrement this, and that made our function work correctly. So as you just saw, we have the hex decoded, converted back into hex, the base64 decoded and then converted back into base64. So every function seems to be working correctly, and that's something I really want to drive home. It's important to test everything. Even though like a lot of the times we'll introduce bugs into our code, as long as you're testing rigorously before you send it off, and use the debug tools, you can find everything and make sure that all of your code is working properly. That's really important. So yeah, we were able to figure it out. We were able to use our little handy dandy debugging tool, another reason why Visual Studio is so nice, and I was able to trace it down. Let's go clean up challenge 1 and then push it to the Git repo. Okay, so we can get rid of these cout calls. Get rid of this. Let me just copy this real quick and delete all of this. Throw this in the return statement. And there we go. Challenge 1 is now complete. So I will make sure to upload this to the Git repo, the GitHub repo, and then you guys can, copy the code, change it, play around with it, experiment. Make sure to test everything rigorously, and hopefully y'all learned. Okay, thank you all for watching, and I will see y'all in the next video.